Okay, the topic of this particular video lesson is the trade-off between rotational spin of a motor and the torque that a motor can provide. In one of the previous videos, we looked at a particular motor that was able to provide a maximum torque of 100 Newton meters, and so if you placed a load on it here, just shown as a simple disk that would spin. If you placed a load on it that was less than 100 Newton meters, that represented less of a load than that, then this motor should be able to spin that. But of course, if this disk was something like 110, 120, or 100, anything above 100 Newton meters as a load, the motor would stall. So we want to take a look at the way in which we look at the trade-off between motor and rotational speed. And here is the kind of key image right here. So on this graph, we've got torque as the y-axis, that's the load torque, and the x-axis is the rotational speed. And you'll notice here that there are two key points. Okay, this point right here is the no load speed, so the torque value would be 0, and you'd have your maximum value of rotational speed, so the spin rate of the motor would be greatest right there. And then if the torque were to say increase, let's pick a point here. Let's pick, say, the torque were to increase to this value here. I'm trying to draw a straight line. All right, if that was the torque, typically the symbol for torque is tau, the Greek letter. So if the torque was not 0, so there was some load on the motor, then that would reduce the rotational speed to some number below this value, this maximum omega value. Okay, omega is the Greek letter used for angular velocity or the spin rate. Okay, and if there was a particularly large torque, then the spin rate would drop quite. Whoopsie. Let me go back. The spin rate would drop pretty dramatically to maybe just a third or a quarter of its maximum value. Okay, so the greater the torque presented to the motor, the lower the rotational speed could be. All right, so there's an inherent trade-off there. I'm going to take a moment to think about the power of the motor, and we're going to return to this in another video a little bit later. But let's make a couple of points here. The power that the motor is delivering is the product of the torque and the resulting rotational speed. So you can think of that as the area of this rectangle here. The y value times the x value will give you the area of that rectangle, and you can see that that's not a very big rectangle, and that's a low power situation when you've got high torque but low rotational speed. A very similar area or power it can be the result of very small torque and very high speed. You could spin really quickly, but maybe you're not turning much of anything. Maybe it's pretty close to just the spindle itself. So these two situations are both low power situations. Okay, this sort of maximum power, let's see if we can reveal this here. The maximum power, give me a second. Thanks. The maximum power here is when the torque is at half the maximum torque, and that results in half of the rotational speed. And you can see that rectangle, or it looks in this case a little bit like a square, but that is the maximum power that could be delivered and it's under those conditions at the sort of half torque rating and with the resulting half rotational speed. You can see that rectangle is bigger than either of those two. Okay, One last point to make about this, and that is, and maybe I'll go back to this picture here for a second. We showed that if the torque increased, the rotational speed would decrease. So here's yet one more look at that. Okay, and you can get to a point right here where the torque would be so great that the motor couldn't spin at all, and we call that the stall torque. Okay, so in our example here that we started off with, this maximum torque of 100 Newton meters would imply that the stall torque right here would be 100 Newton meters. Okay, so the load could become so great that the motor would stop spinning entirely. Okay, so there's a little insight into the trade-off between the torque provided, the ability of the motor to turn, versus how quickly the motor can turn, and you can, I think, appreciate the trade-off that as one increases, the other has to decrease. We'll say more about this, or more implications about this, in another video. Thanks.